All right, welcome everybody to week 11, day 2 of IS50A game development. So, yeah, sure. If you guys are missing any of the assignments, just do them over the break. It'll be due on Tuesday. Why not? I don't care. This is not really supposed to be a class that's here to filter people and punish you. I just want you to learn the materials. That's really what I care about. I want you to get the work done and learn and stuff like that. Okay? Only one of you has done the practice math tests so far, so I'm not going to say who it is, but you can probably guess from the Discord discussions. I'll probably put up a midterm due on Tuesday as well. So do the practice things first and see if you understand them, and if not, just if there's any concept that you don't get, just like let me know. They're all pretty basic, like they're just like adding numbers and stuff. Like it can be hard sometimes to just keep them all straight, so you might want to just try writing down. And honestly, I would just go through the practice quizzes and just see which ones you get wrong, and then that will be your guiding star for the midterm. Okay, because the midterm is just gonna be questions like that. All right, let's get Unreal Engine going. Does that do radiosity? That'd be interesting. Let me look at this one real fast. If they're doing bounce lighting, then I kind of want to show that to you. It's kind of cool. So what we talked about last time was direct lighting, right? So if you have a surface and you've got sunlight coming in from this direction, you got light from the monitor coming in this direction, light from monitor number 2 coming in that direction, light from the ceiling, which is off right now, not contributing anything because it's off, light behind me. All of those things add together to add the amount of light incident on a surface. All of them contribute based on the direction. Take the cosine of the angle of the normal vector and the vector pointing at the light source to see how much hits it. And then that incident light adds all together. Light is additive. And then you multiply it by the color of the surface. Okay? And what is you? What are you? Creek assets. Meshes, materials, lighting examples, maps. And then at the end of the day, that's how direct lighting works. In ray tracing, it works a little bit differently. So with ray tracing, what happens is for every pixel on the screen, you shoot a photon out, essentially. Or not exactly a photon, but you can think of it as a photon. And when it hits the surface, it bounces, or it gets absorbed, or whatever. But it hits the surface, and then what it does is when it hits the surface, it sends a ray towards each of the lights that are possible to hit it, and it sees if those lights can see the surface. If it can, they get directly lit. Here's the other thing. It'll also scatter random rays in other directions. This is all pitch black, isn't it? It's not very useful. All right. There we go, bounce lighting. All right. Now, when you, lighting needs to be rebuilt. All right, I'm do that while I talk. Where did you go? Build, options, lighting quality, high. And we will come over here and build lighting only. Okay, so let's say that you have a bright light shining on a red wall, like we do here. The light doesn't just stay on the wall. The light in real life will come off the wall as well. Photons hit, photons come off. And so what you'll see in real life is this. So you see how there's bounce lighting here? The backside of this sphere is not lit by the light here. What's happening is that the light is hitting the red wall. The red wall eats the green and the blue light. Red light will reflect off in different directions, and it has the effect of illuminating the backside of this concrete ball here red. Okay? This is called bounce lighting. Sometimes called global illumination, where you don't just figure out direct lighting. Direct lighting is what the light bulb can see, right? you can also see the baked shadows don't move. So when you pre-compute lighting, the shadows get baked into the wall. It actually creates what's called a shadow map. The shadow map holds which areas are lit, which areas are unlit. Undo, undo, undo. Doesn't matter. It still says lighting needs to be rebuilt, whatever. All right, I'll just move this down a little bit then. Let's rebuild it. There we go. Rebuild the lighting. Even if you undo it, it still invalidates the lighting. It's really weird. Just gonna be rebuilding while I talk. So, what happens when you have global illumination is that you have to realize that you don't get light on a surface just from the lights. You get light from everything else around. And traditionally, we kind of hack around that using ambient lighting, right? So just based on the ambient amount of light in this room right now, we'll cheat and add a little bit of 0.3, 0.3, 0.3 to every surface. And if it's daytime, outdoors, 0.8, 0.8, 0.8, whatever. We add a lot of ambient lighting. But if you want it to look good, then you have to do what's called bounce lighting. And so with bounce lighting, you've got direct illumination, which is this, right? And then when it illuminates a surface and light comes off of it, it'll cast rays in different directions. The more rays, the higher the quality you get. And it will light the backside of objects as well. So you can see here we've got a yellow cylinder, and it's casting a shadow here. And let's see if we pull this here. Let's see if we can get some yellow light off of it. Rebuild the lighting. You see how the baked shadows are still there. So let's see if we can get some radiosity off this yellow guy here. And we should pick up a little bit of yellow light here. It's going to be pretty bright, so we might not see it. Okay, so it seems like most classes are just in existence to punish people. Yeah, but this is game development, man. Like, it's not here to. I'm not here to like sensei death laser you. You know what I mean? Like, that's what Japanese is for. If you want an easy class, take Mandarin. It's true, though. It's so true. Mandarin is so much easier than Japanese. All right. So let's see if we picked up some indirect. Yeah, you can see how there's a little bit of yellow here. And so it gets very complicated. It gets very expensive. Like the more photons you send out, the better the quality you get. Even still, you'll get splotches and speckles, and so they'll do filtering over it to sort of average out where the light rays end up and stuff like that. It gets very complicated. But the good news is we have hardware ray tracing now. So if you are a person like me that owns a 30 series video card, as of 20 minutes ago, just arrived. Unfortunately, not a discrete graphics card, because those things are still bloody impossible to find. I bought a laptop with a 30 series video card in it. $1,000 has a 3060 in it. Considering that 3060s, it's probably the mobile version, which is a little crappier than most. Considering how much 3060s on their own are selling for, it's like, it's like, yeah, it's a pretty price. Let's see, 3060 Ti on Newegg. How much? Pre-built systems, the only way of getting them, $600, right? So it's a $300 graphics card selling for $600, and it's still sold out. It's sold out everywhere. So what I got was a gigabyte. It doesn't matter. Whatever. It's a gaming laptop. I'm going to be in San Diego over the weekend, over spring break, and it's got a 240 hertz monitor. Yay! 3060 graphics card. So I'm excited. Anyhow, the point is, if you have a 20 series or a 30 series graphics card, then it will do hardware ray tracing, and so these sorts of computations can be accelerated by the graphics hardware, and they can actually go reasonably fast at reasonably good quality. A card that normally costs $160, like the 1650 Ti, is now $650. I know. It was really funny. Like, I was going to sell my 2080 Ti. After the 30 series came out, the price on it plummeted. It plummeted to like nothing. And I was like, okay, I guess I won't sell it then. Whatever, I don't care. And then the 30 series came out and nobody can get one, and the prices of graphics cards. Like, I could sell my 2080 now for what I bought it new 3 years ago, or 2 years ago, whatever it was. So, yeah, I'm still using a 3-year-old graphics card because I have not been able to find a 3090 at anywhere near MSRP. So, scalpers, got it all. Okay, so that is a little bit on lighting. You guys understand? Direct lighting, indirect lighting, global illumination. And so with global illumination, actually, the surfaces that you light with bounce lighting, they themselves become lit, and they can light other surfaces as well. And so what you end up with is, even if you just have one little hole in a roof with light coming in, that light will start bouncing all over the place using the photons and kind of create this really nice, natural-looking illumination in a thing. So like Quake 2, which has really horrible graphics, has a really nice RTX mod on it. Let's see if I can find the pictures. Yeah, here. It's got a hole in the ceiling, and this becomes brightly lit. And so if you're lighting this surface, it'll scatter photons in different directions. Some of them will pick up the sunlight, but a lot of them will pick up the bright light here. And so you can see, like, having a beam of high light coming in there will actually scatter and globally illuminate a... this is what it looked like originally. So it looks a lot nicer now. You got the light shafts coming down there. See, that's very flat. You know, the lighting in here is very flat. And here you got this nice illuminated scene. The graphics are still like, you know, count the polygon kinds of things. They probably really should have upgraded the monsters and stuff like that too. It looks pretty bad. So I saw the talk on how they did this. Pretty cool stuff. Pretty cool. All right. So hardware acceleration on ray tracing is kind of the next big evolution in video games. If you guys take IS-50B, I've got a lecture on it in there. You can learn about it. They say it should go back to normal pricing, and I hope so. I hope so. I am ready to run Age of Empires 2 on a 3090. Europa Universalis as you've never seen it before. Just imagine how good that game would look with ray tracing turned on. You'd see every pixel. Yeah. I already beat Cyberpunk, so I don't really care that much anymore. I wanted it for Cyberpunk, but as it turned out, Cyberpunk kind of, Like, I don't regret playing it, but it wasn't as good as they said it would be. Yeah, let's close out of this, I guess. Save you, bail out. Okay, so let's start talking about your projects. So let's talk about what you know. Might be good. Could be better. Still poured 120 hours into the game. Yeah, I 100%ed it. I did 100% Cyberpunk. So yeah. The in-game grind was pointless and stupid and boring. But up until the in-game grind, where you 100%ed literally everything on the map, it's pretty fun. All the storyline missions I enjoyed. Most of the side quests were pretty fun. It just wasn't very difficult. The difficulty on Cyberpunk I have real issues with. It was kind of like if they're higher level than you, like it's bullet sponge territory, like you just sit there and pour bullets into them. You'll still win because your bullets can go through walls, theirs can't, so you just sit behind cover and shoot them in the head 50 times with a sniper rifle till they die. You can still win, it's just boring. So let's talk about what you know. I really don't like games like that because it's not realistic. Like, you know, in real life, if you sniper rifle somebody in the head once, they're going to be having a bad day. You know, maybe with cyber augmentations and a cyber skull or something, I can see, you know, somebody having a little bit, but 50 times head, like, come on, dude. dude. Like that should never be a thing, you know? All right. So and they do like 9 million damage to you if they're higher level than you too. So all you can really do is just hide behind a wall and shoot them. All right, so what do we know? We've learned a lot of stuff this semester, and I'd like for you guys to put it all together and put together like a little playable demo of the game. You don't have to make a full game, but I want a playable demo. And then we're going to move in the last quarter of the year into working on a real game, or yeah, modding a real game. Maybe they store their brains in their chest. Yeah, maybe. I don't know. All right, so what have we learned so far? Why don't you guys type out some things you've learned? And I'll type out some things that I've taught, and we'll see if they match up. All right. So first things first. Basics of an Engine 4. Place objects. Everything or math related, everything you know, because I want you guys to have a menu of like the tools you have, like what you've learned, so that you can put them together to make a game. Yeah, skeletons, sure. Animations, sockets. Trace line, touch, think, the 3 T's. Trace, touch, think. For interacting with the world. Timelines. Animations. HUDs. Yeah. Simple HUDs. Hey, Bern, you feel more confident at making HUDs now? HUDs with images and text. Yeah, simple things. Like the most primitive kinds of HUDs there is. But yeah, it's. I think after seeing how complicated even that could be, I'm pretty sure you liked that version more than the more complicated way of doing it. Complicated way looks better. Yeah. Opening, closing doors, touch, overlap. What about setting up input? Setting up keybinds. Right? Do you guys remember how I did that? I taught it. I don't know if you remember it. Yeah, printing strings. Yeah. Very important. You know, some people like they like having the blueprints open while they play their game, and then they can see visually which way the control flow is going. I just print strings, man. Because if I ever get to the point where it's not printing the string, I know it's not getting there. And if it does print the string, and then I hook up the draw texture, and the draw texture doesn't appear, I know the problem is with the draw texture and not the rest of it. It's really important in computer science and life in general to be able to home in and isolate where your problem is. Right. So if your code is printing "Hello World" when it should be drawing, Pepe or whatever on the screen, and then you take that out and you put the draw texture and it doesn't draw, the problem is with that draw. Maybe the width of your image is 0 or something like that, right? And so you need to be able to isolate exactly where the mistakes are occurring, and print string is, shameful display, but I don't care. I use it. It speeds up my development. Spaghetti can get nasty. Yeah, we should probably go over managing spaghetti, maybe. Might be a good idea. to do. Tofu to do. Is that how you spell spaghetti? You could print a screen to tell you to click the mouse to see a price. Yeah, but in like a professional video game, generally speaking, people don't like reading. Like, I'm a Unix guy. I like looking at scrolling text, but spaghetti. Arms are heavy. Mom spaghetti. All right. Okay. Box triggers, sphere triggers. Yeah. Ties in with the overlap. Oh yeah, backstabbing, right? Yeah. Oops. How do I do this? Using dot product to tell here same way. Using cross product to tell something is on right side. Vectors. Linear algebra. Scalar. Oh yeah, local and world coordinates. So if you want to make a rocket appear in front of your plane, are you going to use world coordinates to do that or local coordinates? What do you guys think? When should you use world coordinates? When should you use local coordinates? Sure, I'll just draw it. I've got one node open already. Other to-dos, we got AI, AO, Let's say you've got a rainbow colored airplane. Okay, it's flying through the air. And the origin is here. Let's see. You've got a little rocket attached on each wingtip. And the user hits click, and click causes a rocket to fire. Let's worry about this one for now. How do you determine, like, are you going to use global coordinate space? Like the world origin might be like 10 kilometers away. Are you gonna use world coordinates, or are you gonna use local coordinates to fire this rocket? I mean, you probably could, you know, like take this position minus that position. But how do you know? Because airplanes can yaw, pitch, and roll, right? Like which way is forward, which way is the wing, you know, that kind of stuff. Is the only benefit to local smaller numbers? Yeah, kind of. But here's the thing: it's like the world has like the x-axis and the y-axis and the z-axis, right? And if I want this rocket to come out, I could figure out its location in either coordinate system, right? Like in local coordinate space, you have what's called forward, and you've got right, and you've got up. So if we pull back on the stick, the plane's going to go towards up. If you hammer the stick right, it's going to rotate around the forward axis. The forward axis is like this, and it will rotate around it to do a roll. If you step on a pedal, it'll yaw, it will rotate around the up axis. But here, we've got two different coordinate systems. One with the world x, y, z, and then here we've got the local coordinate systems. This is called the world coordinate system. And that's shared between all the objects in the world. This guy's origin here is going to be at world coordinate, y is equal to 10 kilometers or something. In the local coordinates space stuff, you're exactly right. This number is going to be like 3 meters or something, right? Like however big the wing is. And so this guy's location is going to be 0 forward, 3 meters right, 0 meters up. So yeah, it will be smaller numbers. That's true, and it's easier to work with. But here's the thing: like if you have this airplane here, and it's like pointed downwards and rotated a little bit to figure out exactly where the wingtip is and what direction the rocket should be pointing in world space can be complicated, right? Because you've got to be like, all right, got to do a rotation and a translation, and you have to do a vector. Like it's annoying. Whereas in local coordinates, all you have to do is say, all right, spawn actor of class rocket. This is UE4, right? Spawn actor of class rocket at this location, right? And set its rotation to equal ours. Right, so have it pointing in the same direction that we're pointing. And you're done. Okay. And if you want to give it a velocity, so when you create these things, you give it, what are the three attributes of every object? There's location. What else? So when you create an object, you need to give it three things. Right? Location, rotation, scale. But then the most important, actually, four things. There are four things in the Spanish position. It's velocity. Right? So, what speed do we give the rocket? When we give this guy a velocity, we want it moving the direction we're moving, plus, let's say, 800 in the direction we're moving. How do you do that? Using linear algebra. So first of all, you could say rocket's velocity equals our velocity. And then it'll just cruise with us. Plus, what? Something physics, yeah. Remember, inertia is a property of matter. Rocket's velocity, so we're going to start off with rocket's velocity equal to our velocity, so it has inertia from us. But we want it to take off in the direction we're looking at a speed of 800. 800 centimeters a second. I don't know. It's not very fast, I guess. So how do we do that in linear algebra terms? So the base velocity is just going to be our velocity, right? If you throw a baseball on a moving train, you pick up you pick up the speed from the train, and the baseball picks up your speed, and so you're going to throw it at 10 miles an hour past your velocity. Calculate distance. There's no distance. It's just velocity. Remember, velocity is direction and magnitude, right? Direction and speed. So what we do is we say, start it off at our velocity, and then we're going to add 800, it's the speed, times our forward vector. Okay. So the forward vector is very nice. It's very useful. It's the direction we're looking. And so if we want the rocket to fly in the direction we're moving, then, yeah, it'll start at this position, which is our position plus 300 to the right. So you say right times 300. And then its velocity is going to be our velocity plus forward, the direction we're looking in. Forward is always a unit vector, right? It's 1. So it's going to be forward times speed. So it's going to be the direction we're looking times whatever speed we want to give it. If we want to travel 8 meters a second, we give it a velocity of 800, speed of velocity. Speed of 800 times the forward is a velocity. Okay. And if we do this, then the rocket will successfully, we're flying at 500 miles an hour. Click the mouse button, the rocket will take off 800 faster than us in the direction we're looking, starting at 3 meters to the right. Okay? You guys understand? $800 times 1. Well, no, 800 times the forward vector. The forward vector is a direction. It's whatever direction we're looking along the different axes. 0.4, negative 0.2, 0.8, whatever. Right? So that's the direction that it's looking. That's the direction we're looking. And so we take whatever direction we're looking, multiply by 800, and then that's the amount the rocket will move every frame or every second, whatever it is. So it'll move 320 units in the x direction. It'll move negative 160 in the y direction. And it'll move 640 in the z direction every second. So every second it's moving 3 to the right in the world coordinates, 3 to the right in the world coordinates, and down in the y coordinates, and up in the z coordinates. So whatever our forward vector is, that's local coordinates, but by multiplying by 800, that gives us a speed in global coordinates. Speed and velocity will give us a velocity in the global coordinate system. And that's all you got to do. And most of the time when you make a weapon in a video game, there's only really 2 kinds of weapons. There's trace hit scan weapons that do trace lines. So you click the button, laser shoots out, explosion. You did that already. And the other is to have some sort of projectile. So you have to figure out the place the projectile gets created. You have to figure out its rotation, set its rotation, and my rotation is a pretty common one. The arrow comes out in the same direction you're looking, pretty common. Set the scale to 1 usually. You know. And then you set the velocity based on some equation. Like if you're shooting a bow and arrow, the velocity might be based on how long you've drawn the bow for, right? That's how it works in Valheim. If you draw the bow for like a second, the bow, it goes like that. If you draw it for longer, then the arrow comes out faster, right? So, where does the forward vector come from? That. Get forward vector. So for every object in the world, you can get what direction it's looking in. Okay? And so we have a component of us called the first person camera, which is the screen. This is the viewport. That's what's being drawn on the screen. And the forward vector in Unreal Engine is the x-axis. So whichever way the red arrow is facing on that camera is the forward vector on it. And it just returns that. And if we were to rotate this thing around, this, and give it some weird, I don't know, have everything at an angle. Play. I didn't save it. Yeah. Seems like a bad idea. Anyway, undo all that. Then the camera would be at an angle to the gun, right? But that would still be the forward vector. The forward vector is the direction the camera's looking. So when you play the game, the forward vector of the camera is literally the direction that you are looking in the world. And so I just grab the forward vector out, and in this case I'm doing a hit scan, right? Trace line. Okay. But if you're going to do a projectile, what you do is you grab the forward vector, you spawn an actor. If you look at your first-person character, it has the code for that in it to spawn a projectile, and you give it a position equal to your position, often plus some offset. Like in our case, the sphere is that point right there. So you can attach a sphere to a character and have that be the spawn point. It makes it very easy to spawn projectiles because you just have a place. And so what you do is you say get the sphere. So sphere, get the location. That's the location the projectile appears at. Right? In this case, that's the location the laser starts at. And then the place the laser ends at is the location of the sphere plus the forward vector times, I think, 20 meters. So the range is set to, 20 meters. So the forward vector is always a unit vector in a certain direction, the direction you're looking. If you scale it by 2000, that scales it to be 20 meters long, and so it's 20 meters in the direction you're looking. So you move it to the starting by adding it to this. That will put it here, plus 20 meters in the direction you're looking. So that's the ending point for the laser. So the starting point for the laser is here. Here, that sphere. And the ending point is the sphere plus 20 meters in the direction you're looking. That's what this is doing right here. Clean up the spaghetti a little bit. Okay. And so one of the nice things about Unreal Engine is that you don't actually have to do the linear algebra in most of these cases. Actually getting the forward vector out of something when all you have is a rotation is annoying. If all you know is that you've been rotated, this much in the X, this much in the Y, this much in the Z, to actually get the forward vector out of you is actually annoying. You have to do fairly annoying math to do it. It's not hard. You just look it up and Google it, but it's still like this ugly equation. But the good news is like there's abilities to rotate vector, quaternion, random rotator, find look at rotation, find a rotation for an object at start so that it can point at end. And so like if you've got a monster and the monster detects a player over there, then you can be like, hey, what rotation do I need so that the monster will rotate the face of the player? That's all linear algebra. It's all done for you. So all you really have to know is sort of the fundamental concepts of linear algebra. You actually don't have to know the equations too much. Like I make you do the dot product, I make you do the matrix multiplies and stuff like that, so you kind of get a feel for it. But in reality, these are all nodes that exist already. You have to know them if you're going to make something like this. Like if you're going to make a game engine, then you'll have to know all that stuff. I did when I made a game engine. And it's annoying. I spent a lot of time reading through books. Like, how the hell do I rotate? I know how to rotate, then translate. How do I translate, then rotate? How do I put that into a matrix? You're like flipping around through these math books and stuff like that. And it's just a lot easier to use somebody else's engine. I don't think if I had to make another game, I don't think I'd ever write an engine from scratch. It's too much work. It's too much work to write an engine from scratch, honestly. And Epic takes like what, 10% of your game? Who cares? Right? Like, man, it's not very much. UE4 is the game engine, yeah. Well, it's a game engine. There's also Unity. Unity is very commonly used. Valheim is on Unity. Cyberpunk was on their own game engine, and look how well that worked out, huh? CD Projekt Red, huh? I played another game recently that was on the CryEngine, the Crysis engine. I think that was Hitman. I think Hitman's on the Crysis engine. Yeah, there's a few major game engines out there. I like teaching Unreal Engine because it's in C++. It's written in C++, and when you write code for it, it's in C++, and I teach C++ in my computer science classes, so that's why I prefer Unreal Engine. I also think Unreal Engine games just look better than Unity games. I don't know. Call me crazy, but I think that the games look better. All right. Yeah, but if you understand this, like, you can basically make a weapon, right? How do I place a rocket in the world and give it a speed? Local coordinate system, my right vector times 300. It's 300 units to my right. That's the location. My location plus the offset. Velocity, it's my velocity plus my forward vector times 800. You know, that's why I emphasize all this math stuff to you guys, because you kind of, you got to just kind of internalize it and make it part of your brain. I can show you real code that does this kind of stuff. It's all fairly typical, very typical stuff. What else do you guys know? The game engine is the software that ends up drawing all the stuff on the screen. The game code, which is what I frankly prefer writing. I don't like writing engine code. I like writing game code. I like writing code that says, when you step into a fire, set the person on fire, right? Do damage to them over time. When they leave the fire, I don't know, put it out or something. I don't know. So, yeah, this is a game development class, and so I don't really teach how to make a game engine, but I teach how to use a game engine. And in order to use a game engine, you still have to know some of the linear algebra. Okay, I think that's pretty good. So on Tuesday, I would like for you guys to get in groups, ideally groups of like 3 or 4. I know some people have dropped out. Rivera has dropped out, so if you're in Rivera's group, you'll need to get a new partner or something like that. So organize yourself and come up with a game. I want a proof of concept. I want you to come up. It's like with the game, the board game. I want you to think of something that's fun, like some fundamental mechanic or idea that is fun, And I'm far more critical on issues of fun than I am on technical issues, right? Like if you can't get the HUD to display, that's a technical issue, and I'll help you resolve it. It's fine, it's normal. But fun, you need to make a fun game, and so come up with something fun. Like for example, I've for a long time wanted to make a game called Barnyard Wars, where people are like chickens and spiders and stuff like that, and if you're a spider, you can throw up spider webs that the insect players can't really see very well, and they run into it, and you get points for your team that way, and the insects can maybe harass the humans that are like the big bosses, but can't really do very much against insects unless they have a fly swatter, and and then of course birds can eat spiders, and so you got people jumping between different classes and all trying to earn points for your team. I don't know. It's an idea I've had for a while. I don't know if it would actually be fun in practice, but you'd have very small scale. It's like Katamari Damacy, where you roll up a ball, and Katamari starts very small, you're zoomed in, super small, and you're this little ball, and you roll up twigs and matchsticks and erasers and itty bitty tiny candies and stuff like that. And as you get bigger, the camera zooms out, and you collect bigger things, and then you zoom out, and now you can pick up birds, and you zoom out, and you can pick up cats. You zoom out, you can pick up tables. Zoom out, you can pick up lawn chairs. Zoom out, you can pick up cars. Zoom out, you can pick up buildings. Zoom out, you can pick up entire chunks of city blocks. Zoom out, you can pick up cities. Zoom out, you can pick up entire continents. Zoom out, you can wrap up the entire world, And so the game supports that level of scale, from the very smallest insect level all the way out to rolling up continents on Earth. And that's a cool idea that I've never seen really done anywhere else. It's never been done at the first person shooter level, So I was thinking it'd be really fun to have people playing ants, and All right, get an ant trail going, get that, harvest the food from the picnic the human player left out, and you earn points, and then you can drop out of being an ant and, go into being a bird because some spider on the enemy team has been putting webs, to trap your insects. So hop into being a bird, go eat the spiders, get those guys cleared out, and then of course, you can have a bird of prey that can eat bird but can't eat insects, and I don't know. So so everybody needs to be in groups of 3 or 4 for this project, and all you have to do for Tuesdays is prep, like my buddy Jeff said, come up with a game proposal. Come up with a 1-page. Start off with an elevator pitch. Sell me on the game in the first paragraph, and then just provide some details. What kind of game is it going to be? What genre is it? Doesn't have to be a first-person shooter. We've been doing first-person shooters just because it's a common genre. But you can make a vehicle game, make a third-person character game. All those templates exist on Unreal Engine, and just have something fun. Just have something different, something interesting. It doesn't all have to be original. Most games aren't entirely original, but you need to have something interesting about it. So when people tell their friends, like, "Hey, have you played Blue Deer?" By Team Dolan. It's amazing. There's, animals different colors, and I don't know. Like at nighttime, they're invisible if they're certain colors. I don't know. It's got this camouflage-based system that's amazing, and it really is tied in with the game mechanics and stuff like that. Yeah. So, just have some interesting mechanic. And if you're curious if the mechanic can be done, like, can you turn it into black and white mode? Because deers don't see color as well as humans do, right? They only have 2 color receptors. We have 3, most of us. So deer are all colorblind, right? Or we would call them colorblind. So, maybe you can make a game that plays on that element. I don't know. And you're like, I don't know. Can I turn the world black and white? And the answer is yeah, you can. It's pretty easy, actually. You make the world black and white very easily. So, you get a power up and you can see more colors. Like I actually had a group that made a color-based game. It was inspired by the Brent Weeks series, the Lightbringer series. I don't know if you guys have ever read fantasy novels. Brent Weeks is one of my favorite authors. We're friends on Facebook. He's a cool dude. And the basis of the game is that there's different colors of magic, and he had actually not heard of or played Magic the Gathering before making the Lightbringer series. He played it afterwards and actually incorporated some fantasy version of Magic the Gathering into the World Series because he played it. He's like, "Oh, this is a really fun game. How come nobody ever told me about Magic the Gathering before?" And so he actually added it into his game. But there's like green magic and yellow magic and orange magic and all this kind of stuff. And so my students were inspired by his series. And you are trying to escape from a prison. Like one of the main plot points of the first book is this guy's in a dungeon with only one kind of light. And since the different kinds of light allow different kinds of magic, he has to use what he can, make in a green only world. And so he ends up cutting himself to get red. And so he uses the red of his blood to, escape from the first prison cell. And then he's in a second prison cell that's all blue, and he's got to, and so, and so they had a game that was based on that, where you could switch between the different colors. And if you look at a light of a certain color, it enables an ability. It charges up your mana bar in that color. And then you can go and you can do things with that color. For example, with green, you could push objects and things like that. But it burns your mana, and you got to go and look at the green again. And so by moving blocks around and standing on it, you can see the green down there. It was actually a pretty good puzzle game. It's a pretty good puzzle game, all color based. So that would be an interesting mechanic. I'm not telling you to copy it. You shouldn't. I'm just giving you ideas that, like, of like different, and you don't have to make a giant AAA title. You don't have to make BioShock Infinite or anything. Just make a proof of concept of the game, right? Enough that you can play the game and be like, yeah, okay, that's fun. It's fun. All right. So proposals will be due next Tuesday, and then after that you'll have about a week to actually do it. If there's any things that you guys need, like multiplayer, I'll find that out from reading your proposals, and so I'll give a lecture on whatever pertinent, important. Multiplayer is pretty important. I should probably do that anyway. You want to have monsters. We can talk about a health system today, I guess. That could be pretty useful. Most games are going to have some sort of health system, right? So, any comments? Inventory system? Yeah, sure. Do that. Switching weapons, or just having different items on you. Sure. The HUD, you can actually do markers. So you can make it so that there's like HUD markers, world markers. You know, like when you have a quest, and it draws like a little triangle, like, here's the direction. It's like leading you by the nose to Mankirk's wife, you know. Herbs, flowers, sure, okay. Compass, yeah. The compass, I think you could probably do the compass already, because it's just a texture that's at the top of the screen, right? And so all you have to do is get the rotation around the z-axis. That's what direction you're looking in, and you slide the texture. Remember how we talked about that, the UV coordinates? You can use it to slide a texture around. And so you just have a texture, you know, and you probably steal it from some video game. Wait, this is on YouTube. Don't steal it from a video game. Oblivion Compass. No, that's not Oblivion. Yeah, it's Skyrim. But, you know, they have this little thing up at the top here, and all you have to do is slide the texture around using the UV coordinates. It's not very high detail. It's so low res. Yeah, you just basically slide the texture in the middle around based on your rotation around the z-axis, right? Because the z-axis is up and down, so if you rotate around the z-axis, it's the direction you're looking. And so that'll give you a number from 0 to 360. You slide you divide by 360 to get a number from 0 to 1, and you slide the texture from 0 to 1 based on that. And that's it. Probably do that already. A lot of these things, which sound really complicated, like aren't really that bad. Be prepared to hit up YouTube videos to figure out how to do things. But I would start with me first, honestly, because I know how to do most simple things. So you guys want to, what do you want to learn? Crafting and building? Dynamic, no. Minecraft, like, no, I can't help you with that. I've never done that before. Right after I say, I know most simple things, yeah. Sorry. I can't help you with like a Minecraft or the Valheim. I mean, I know roughly how they do it, but I've never done it in a game before. Yeah, okay, let's do inventory. It seems like fun. Save, and you guys should have a copy of this notebook, right? I shared that with you guys last time, right? So let's do an inventory system. So let's put some herbs on the ground. Fortunately, we still got the flowers and plants nature pack. So, why does the flowers and why does it have a animation in it? Strange, very strange. It's got bridges. Look at that. You guys want to do a bridges assignment? Beautiful. Look at that. Look at that. Tiny little bridge. Not quite what I was going for. There we go. Looks horrible. Just delete that. Okay. So herbs. Let's put herbs on there. Drop a planter maybe right there. Scale it up. Okay. And then let's put a ageratum in here. Scale. Thank you. All right. So we've got a flower there. And so blueprint. What does it do? Run construction script. Oh, by the way, this is how you manage spaghetti. You can take any chunk of code like that, and you can say collapse it to a function, or collapse it to a macro, and it just replaces it with one node, right? And so the macro is kind of local to the the blueprint. But if I were to instead collapse it to a function, then that function could be called by other blueprints as well. They basically do the same things. Collapse, and you just hide it if you want. So if you ever get tired of all the spaghetti out there, that's a really nice way of doing it. Also, if you're repeating the same things over and over again, then turning it into a function is actually really useful, because then you can just call the function over and over again instead of copy pasting over and over again. If you ever find yourself copy pasting like this is doing here, it should probably be a function. Let's not save you. Just close. All right, so let's get you into the planter. Okay, so Habern, you want to make it so like when you walk up to this thing, it'll pick it, right? Something like that. What's your favorite color? Red. No, blue. Ah. I played that for my daughter the other day in the Spanish Inquisition. Okay. All right. There we go. And then be able to hold on to it in inventory. Okay, sure. So let's just do one flower first, and we can worry about the other ones later. So what should we do? What should we do? What should we do? First person blueprint. So we got our first person character. So this seems like a good place to have a variable. And so the simplest thing would be to just have a variable saying holding flower. You know, I don't know what kind of flower that is. Okay. Or, you know, you can make an array, I guess, for it. Now we're going to make a function. How do we want to do this? Let's make a variable. And this will be called inventory. And we also need health. Yeah, okay, we do have health. We'll make health public, make inventory public. And so you're going to make a bool array. Do you want to be able to have multiple flowers or just like one? What do you feel like? Do you wanna have like a count of how many of each type of flower you picked up or something? More than one? Okay. So make an integer 32 array called inventory. Compile. Save. Alright, so default. Let's pull that down here. Default value inventory, none. Instance editable. Tooltip. Holds what flowers we have. Category, whatever. Application. Only there's a plus on an array. Does the player see the tooltip? Nope. The tooltip is for you. So when you mouse over it, it'll tell you, the programmer, what it does. Left click to select, right click to top tabs. There we go. It's an array of arrays now. Shoot. All right, let me try this again. Make a int. Let's make an int. Integer. Inventory. Compile. Save. Okay, so it's an array of integers. There we go. There's the plus. Okay. All right. Yeah. So make an integer and then right click on it and it turns into an array. Cool. All right. But if you make an array of integers, it doesn't. What values we have? Yeah, basically nothing gets exposed to players except what you see in the game. Right? And so what we can do here is add a couple different elements. And these elements would be 4 different counts, right? So maybe there's going to be 4 different types of flowers. Element 0 is the purple one. I don't remember the name. Element 1's the red one, whatever. And so you can do that. And this is a public variable now. Okay, compile, save. Okay. And then maybe on the heads up display, we can have it print how many purple flowers you have. So if we go into first person HUD, oxygen bar, near frosty, death. Alright, draw texture. These out of the way. See how managing spaghetti is very important. Alright, so these guys will come into a new branch here. And we want to, if the user has a flower draw on the screen, you have a flower, or you have X flowers. Okay. So from the first person character, we're going to pull out the first person character, and we are going to say get inventory. That's going to return an array. An array is arrays. Don't sing death metal, kids. It ruins your voice. Okay, an array is a different kind of variable than what you're probably used to working with. Okay. So normally a variable is just like it's going to be true, it's going to be false. When you pull out from an array, there's only really a couple things you do. You loop over it, but in this case, I'm going to call get. And so I'm going to get element 0 from it. And element 0 is going to be the number of purple flowers I have, right? And so I'm going to pull the result of this over here. And I'm going to say if that is greater than 0, greater than integer, greater than 0. So if the number of flowers, purple flowers we have greater than 0. I gotta write these things up. Okay, so if the number of flowers we have is greater than 0, then we'll do something. Otherwise, we'll move on to the next step of the HUD. So what are we going to do? We want to draw a string, maybe. What's it? Draw. Text. Okay. So we're going to draw text. Text color will be garish purple. What location are we going to draw the text? That's a good question. Let's move it down 800. No, that's to the right. 800. Move it down 800. 800 pixels down. The font, we don't have a font, so who cares? Scale position. Should probably use that, but whatever. All right, so what text are we going to draw? We're going to draw how many purple flowers we have, right? So that number there is the number of purple flowers we have, so we're going to just drag that right into there, and you'll see that it's going to cast the integer to a string and then feed that string into the text to draw. There's actually strings and texts, which is a weird thing. A string is kind of like an array of characters, and a text is something that gets displayed on the screen. It's kind of a weird thing. Okay, so I'm just going to actually start off with this greater than or equal to -1, just because I want to see what it looks like. So let's go ahead and hit play. And you can see very, very tiny on the left-hand, very left edge of the screen, it's drawing 0. So, yay. All right. So, scale, we need to scale that up 8 times. Yeah, let's move it right a little bit so it's not quite on the left edge. Do you guys see this? Like, when I'm doing development, I just do a little bit at a time, right? Hit play. There we go. 0 flowers. Again, use UMG, kids. Don't do as I do. All right. So that shanty voice, right? South Australia, I was born. Heave away, all away. South Australia, round Cape. Around to South Australia. All the way, you rolling king, sing, heave away, all the way, you'll hear me say, we're bound for South Australia. Okay. So let's make the heads-up display a little bit more interesting. I'm going to append purple flowers before the number of purple flowers and feed that in here. Compile. Save. Play. Now you can see it's printing the number. It's a little big now. Scale 4 times. Yeah, that's all right. That's all right. Okay, so we got purple flowers now. Now we just need to make it so that you can actually walk over here. Look at that planter's a little big. Scale that down a little bit. Let's try that. Let's see how that looks like. Just a little bit too big. Then you, my friend, you get moved. I'm going to do the dangerous 3-way move and see if that works. Nope. Yeah, it looks good. All right. So what I want is when it walks up, it picks the flower. Okay? And it increases our inventory. So we are going to turn this flower into a blueprint. And if I wanted to be cool, I can make it more complicated. But I'm not, so I'm just going to turn this into a blueprint, and this is going to be called Ageratum Blueprint. Let's call this pick flower, picking flower blueprint. All right, select, and thank you, autosave. Very cool. Okay, so there is our blueprint. See, there's not a whole lot on it. I'm going to add to the static mesh component. I'm going to add a component called.
Why are you clicking on a flower? Dad, why are you clicking on flower?
We're going to make it so you can pick a flower. Do you approve? So we're going to add a sphere collision to it, and this will be called
Pick a flower.
Sphere. It's already called pick a flower, bro. The whole thing's called pick a flower. The collision we're going to call sphere trigger. So if they get that close to it, let's see. Yeah, it's pretty good. Here. You can always look at the real world and kind of see how it looks. Okay, that looks pretty good. All right. So compile, save, sphere trigger. It's pretty good. And so on event begin overlap, what's the first thing we do? It's the first thing we do. Cast a spell. That is correct. Wait, no. Print string. So we're just going to print pick a flower. And the reason why we do this is because there's actually multiple levels of where collision can take place. And if it doesn't work, it doesn't work, right? So come up here and it printed pick a flower. Cool. You guys see that? Pick a flower has been printed. So we know that it's activating.
Wait, can I pick a flower?
Okay. So you want to pick a flower? Where are you? It's not picking it. When you walk up to pick it, all it's doing right now is saying pick a flower. And we do that just to make sure that the collision is working. Because like what if there's something up here in the parents that disabled all collisions or something like that, then this wouldn't trigger because it's a child of it. And so you've got this parent, and a child, and if any of them have their collision settings set wrong, if we click on sphere trigger here, you can see that it's got down here under collision, it does generate overlap events. That's the key thing. So that when somebody walks over the sphere, it'll trigger the begin overlap. And then it's got these collision presets that choose the kinds of things that it will block, what kinds of things it'll overlap with. And if any of these things are set improperly, nothing will happen, right? You walk into it and nothing happens. And that's why I always start with print string, like, all right, cool. All the different levels are all set up properly. Okay, cool. So now, what should we do to pick a flower? What should happen in the game world, Data?
You should.
So my students aren't talking on Discord.
So you
students on Discord, what should we do also? You can chime in too.
So you should walk up to it.
Okay.
Look at it.
When we walk up to it, this happens.
No,
so drag out from that. So when we walk up to it, what should happen?
Nothing.
Nothing? I thought you wanted to pick the flower.
Yeah, but you have to look down at it and then click to pick it.
Oh, you want to click to pick it? Well, that's an entirely different thing entirely. We'll do that next. So I was thinking just you walk up to it and you just collect it. I don't know. It's like in a video game. You just pick up things. You need trace lines for us to look and then click. Yeah, and it would be in a different blueprint, right? In a different blueprint, you click and it does a trace line. If it contacts the pick a flower blueprint, then yeah, so that'd be a different part of code. Dolan wants it to disappear.
You know that in real life, in a video game, if they made it like if you walk by something, it'll just pick it up. You know that your inventory is going to fill up very quickly.
That's true. That is true. So Dolan said make it disappear. So we walk up and bloop. Your reaction is so cute.
Maybe the flower should disappear, but the stem part stays.
We're talking about doing 3D modeling now, girl. Your daddy's not good at 3D modeling. Yeah, I can't help you with that. Like make it stick to the character instead of disappearing. Interesting. All right, so we could have it maybe make a socket and have the flower appear and attach to the hand or something like that. That'd be cool. That's a good idea.
Dad, can you start playing again? I want to show them something.
All right, go for it.
If you know who's the
Socket.
true master wearing flowers? This guy right here.
Yeah, he's got a flower on his head. Yeah. So like that, Dolan. You want it so when you walk up, like flowers just start attaching to the gun. Something like that.
I want to make
That'd be cool.
Stop moving, flower guy. I want to turn your flower flammable. Why is
You clicked on the video screen.
Oh.
So click back in the graphics there.
I want to.
Did I shoot the flower? Oh. How about we do the what Hayburn was asking for earlier, here, and do an inventory system, right? Then we can talk about attaching it. So, which is a great idea. I love the idea stuff. So, maybe as you go around, your character is just progressively encased in flowers. It's called Hay Fever Nightmare. You're running through a meadow and just like pollen is stuck to your face. You're like, no. The quest for Benadryl. All right. So let's do the destroy last, right? Remember, if you hold down Alt and click on a thing, it disconnects it. Or you can always, if you want to disconnect something, you can always right-click on the socket and choose break. That's another way of doing it. So we want it to. Yeah. So let's do exactly what Hayburn said. We want to cast to. Yeah. Okay. Good. Cast. Very good. Exactly right. Cast to first-person character. Like that. So Hayburn, you were exactly right. The first thing we should do is cast a first-person character. It's just my paranoia about having things not work, which has happened to me a lot of times. There's some setting, there's some checkbox that was not set, that should have been set, and you walk up and like literally nothing happens. So I always, just paranoid, I always print the string first. So, but you're absolutely right. The first thing we should do is cast first-person character, and now we can pull out of this. If this was successful, we can get inventory. All right. Get inventory, and we can, it's over here, and we can get copy. We can get a reference to 0. So that is our purple flower index, right? And then we are going to add 1 to it. So it's an integer. So we're going to increment it. There we go. So that is going to add 1 to our purple flower count, and then we're going to destroy the actor. So let's see if that works. There we go. Purple flower is 1. Cool. Okay. So let's bail out, I think. Yeah. Why do you always do this to me? All right. It's like gray on gray. You can't see where the title bar is. Okay. So, so now we can actually just drag out. Why are you in here? Now let's cut and move you into Bill, where all my other random stuff is, and paste. Nope, you don't like that either. Let's drag you into Bill. Move here. All right, and then if we just toss multiple of these flowers on the ground. That. We just walk over here, pick, right? You can always tweak the radius and things like that. So, what do you guys think? Kind of cool. Yeah. And you just do the same thing for the other flowers, except instead of using index 0, you would use index 1, right? So. Right here, where we're getting index 0 of the array, You pick index 1, and that would be our red flowers or blue flowers or whatever. And so we've got 4 different elements of this array, and so you can access them all individually. That's the general gist of it. So that's a very simple inventory system. You just create an array, just read and write to the different elements of the array, and you can visualize it using the HUD or whatever. Now, Dahlin wants to did this move? Did move. Damn. I think I deleted that by accident. All right. Pick, 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 pick. Okay, so I like Dahlon's idea. Let's make a socket on the skeleton. So first person blueprint, first person meshes, no, first person character mesh. There we go. So we've got our skeleton mannequin arms. We got our skeleton. All right, so we got our skeleton here, which is just a pair of arms, really creepy. Physics. We got the mesh arms. Either way, we can add a socket to either of them. So let's maybe pick lower arm right there. So that spot right there, we're going to add a socket to it. Right click, add socket. And this one, F2 to rename, we're going to call this flower socket. And we'll zoom in on here and move it to like the back of the arm. So like, when we pick these things up, we'll just stick them onto the back of the arm. Okay. All right. Okay. So now, I save that? I did not. Okay. Save that. Okay, so now we need to attach, rather than deleting the thing, or maybe, maybe we do want to delete it, but we just want to attach like a copy of the flower to it. Because this blueprint here has a collision zone on it. So if we attach it, we're going to be walking around colliding with things left and right. How do we want to do this? We can turn off the collision. That's one approach. So let's go back into picking the flyer blueprint. So rather than destroying the actor, we can destroy component. So we will just turn off the sphere trigger. Okay. And so just this part will go off, right? So the sphere trigger will go away. Can we attach a copy with no collision? That's what I was thinking. Yeah, that was the other idea I had. So you would just spawn a new actor and attach that. I don't know which is better, but watch here. We go up here, we pick it, but now it doesn't go away. You see how the sphere trigger is gone, right? So pick. So I don't know. Maybe. Yeah, I don't know. I kind of want to play around with it a little bit. So let's go back in here. And so right now, we're gonna turn off the collision on it, and then maybe we should shrink it a little bit because I think this thing's a little bit big, right? So maybe we'll scale it down a little bit, like set scale. Set actor scale 3D, and we will give it a smaller scale. I think it's a little bit big right now, so let's scale it down a little bit. Okay. And then we're going to attach. So attach actor to actor, attach actor to component. Let's see what I want. So first person character. We're going to get the arms. What are they called? First person. What are they called? are the arms called? Mesh 2P, is that it? Okay, Mesh 2P. All right, so we'll pull off from this. Get Mesh 2P. Get mass. I just want get all socket names. Get socket location. Get socket rotation. Just get Mesh 2P. No. So we're gonna get the arms, and then we will get socket. Can we do that? Get socket. Get socket bone name. Get direction between sockets. Get all socket names. Get attached socket name. Get the socket attached to. Get attached. Get socket location. Get socket transform. Get this. Get all socket names. It's an array of names. Actor scale. Let's see. Attach. What do we want to do? We want to attach us, right? So we want to attach. Okay, so we're going to attach us to attach target. That. And the socket name, what did we call it? Flower socket? Is that what we named it? If we attach a copy with no collision, the original could go away, and then we would attach a copy. Yeah. Either way, the process is going to be pretty similar. What do we call it again? Called skeleton mannequin arms. Good point. Flower socket. Okay. You have to spell these things exactly right. Flower socket. Okay. Let's see if this works. Hey. All right. Oh, it shrank. Bloop. Bloop. It's not attached to me, but it shrank. That's cool. All right. All right. It's not static. Let's see. Attach. It's not static in Blueprint. Cannot attach. Picking a flower. Just static. Oh yeah. Flowers have to be not static. Right. Okay. Picking a flower blueprint. Save. Compile. Can we set the default? Can we set it? Static mesh. Movable. There's a better way of doing this, but whatever. All right, everyone's movable. Let's see if that affects it. I don't get how it's so slow to save. All right. Play. Oop. All right, it's attached. Maybe, I don't know. Just realized I can't actually I can't actually see. Can't actually tell if it's attached or not. You can't actually look down at her own arms. All right. maybe we should attach it to the quick point or something. That might appear. It's very small now too. Come to think of it. We call it grip socket. Let's try attaching it to the grip socket, which is where the hand is. So that might show up. If we don't do that, then we'll need to... No. It's not. It's kind of hard to tell. But, you know, that's the general idea. I can figure it out later. We're out of time for today. But that's the general idea. So you can attach things to other things and have them fall around. You walk over something, you can shrink it, make it bigger, make it disappear. You can destroy parts of a thing. Yeah. But the general way of doing an inventory system is you have your player. The player has different inventory slots on them. Slot 0 is going to be the purple slot, or you can make separate variables for them if you want. You can just make a variable on it called number of purple flowers, and then you get number of purple flowers. It's up to you. Can be useful though if you want to do things like add up, like if you've got 50 different inventory slots, then you probably want to put it into an array, and then you can like iterate across the. Anytime you have an array, you can do a loop for each loop, and so. Anytime you have an array, you can do things like this, where you can do something on every element of the array. So, for example, you can display flower. Instead of having to copy and paste the code, you can have it iterate across every flower you have and do something. But yeah, so you just have different inventory slots and add to them and figure that out. It might be working, might not be. It's hard to tell because you can't really see anything. So. All right. Yep. So that's it for today, guys. Think about your games. Think about the cool stuff you want to do in your games. You've got most of the basic tools you need down. Everything from making worlds, landscaping, textures, animations, the linear algebra you need to succeed. So you should have the basic tools, and for the things you don't know, ask me, or YouTube videos are extensive on the subject. So for the spring break, have a great time. Make sure you get out in nature and hike and explore and stuff like that. But all you have to do for this class is take the midterm. The midterm's all linear algebra, so take the practice quizzes. Try them out first. The midterm's going to be just like the practice quizzes. That'll be due on Tuesday, and then work with your groups, and just put together a little one-page proposal on what you're going to do. And that'll be in the game design category. Okay, that's it, guys. Thanks a lot. I'm going to go eat some food or something. Maybe sword fight. Sword fight first, then food, or food, then sword fight. One or the other.